I'm Jennifer. So this is my uniform mid-unit assignment. So first of all, for question number 4, this is basically asking for the trigonometry trig equation. So this is the basic equation we're going to use, where A is the amplitude, B affects the period, C is the horizontal shift, and D is the vertical shift. So to use this, the first thing is to determine the max and min. So looking at the chart over here, you can see January is the minimum because it has the lowest Celsius. And the maximum would be July, where it has the highest Celsius. So to find the amplitude, we're going to plug in the equation where A equals max minus min divided by 2. So it would be A equals 21 minus negative 24 divided by 2. Since the graphs start at the minimum, so this reflects that amplitude would be a negative number, so it would be negative 22.5. So to find the vertical shift, D, you have to plug in the formula where D equals to max plus min divided by 2. So it would be 21 plus negative 24 divided by 2. Negative 3 divided by 2, it would be negative 1.5. So for B, the period would be 12 because it is from January to December and it is the full cycle of a year. So B will be 2 pi over the period. It'll be 2 pi over 12, which is equals to pi over 6. For the phase shift, we know it is 7 because start at the maximum, which is July, and the maximum is the 7th of the month. 1, 2, 3, 4. The 7th of the month. So C equals 7. So combining all of these together, the final equation is y equals So for A is asking to sketch a graph, and here is the graph I made, where it starts at time equals 0, and when it reaches 12 seconds, it reaches the highest maximum at 11 meters. And that is halfway through the reel. At the end of it, it's going to go back to 1 meter, where it's going back to the same spot. And the midline is 6 meter, where is the dashed line right here. So for part B, we need to write a trigonometric equation. So let's use the equation we were using before, but this time it's time and height and time. Okay, the amplitude would be -5. Vertical shift the period is 24. So if the period is 24, b would equals to 2 pi over 24, which is pi equals 12 over 12. So there's no horizontal shift because we start at the minimum. So adding all of these together, the equation will be -5 cosine pi over 12. There's no c, and plus 6. And for c, so we just plug in t equals 20, t equals 12. There we go, 11 meters, so my equation was correct. And why this provides a good check of the accuracy of the question is because we know that when looking at the graph, we know that when the time is at 12 seconds, it reaches its maximum, which is at 11 meters. So if I plug in 12, it would give me 11. What are two more value that would provide a good check? Another two value could be 0 and 24 because it is where it reaches the minimum, which is at 1 meter. So when I plug in time equals 0 or time equals 24, it would give me 1 meters. Okay, so looking at the last question, we have know that the lowest point is 4.5 meter at 208, and the highest point is at 17.3 and is at 1221. And A is assumed that is to use this as a base equation and create and plug all the numbers into it. Okay, so first we know that the max is 17.3, the min is at 4.5, and the period, it's from 2 o'clock to 2:08 to 8:21. So let's find that out. So to find the period, let's first convert the time into hours. So 8:21 is equal to 8 plus 21 over 60. There's 60 minutes in an hour, which equals to 8.35, and 2.08 equals to 2 plus 8 over 60, which equals to 2.13. So a full period would be 8.35, 2.13, which equals to 6.22. To find this is a half period since it is only from maximum to minimum. So you have to multiply by 2, which is equals to 12.44 hours. So P equals to 12.44. So by using this all the information we have, let's try to find amplitude. So to find the amplitude, same old equation, max minus min divided by 2, which equals to 7.43 minus 4.5 divided by 2 equals to 6.4. And we can also find the C, which is max plus min divided by 2, which equals to 17.3 plus 4.5 by 2 equals to 10.9. So there we got a C. Let's find the K. So the K is 2 pi divided by period. As we know, the period is 12.44. So it's 2 pi over 12.44, which equals to 0.505. And the last thing is the D. So since cosine starts, cosine is a cosine-based function, base equation. So cosine will start at the maximum. That means the D will be the maximum. That means the D will be at the high tide time, which is at D equals to 8.35. So based on these, that gives our final equation, which is this. Amplitude is 6.4, cosine 0.505, t minus 8.35 plus 10.9. So for B, H bracket T is the height of the tie at the pier in meters, and the time and the T is the time of the day in hours on a 24 hours clock. So that's B. Okay, so for C, this is basically just plugging in the time is 11:30. So 11:30 in hours is equals to 11.5. So plug that into our equation, which is cosine equals to negative, which after rounding it equals to 10.8 meters. Okay, the last question is simply giving a restriction that the boat has to be bigger or equal to 12 meters. So the equation needs to be bigger or equal to 12 meters. So I first try to plug this into my equation. So 6.40 S. We're equal to 12, which makes it bigger equal to 1.1.64, which is around 0.172. And cosine, sorry. The inverse time minus 5 is equal to 1.3. And approximately equals to 11.12. So when the time is 11.12 hours, it is when the tie first reaches 12 meters. So because of this, when you try to plug in 5 t minus 8.35 to pi minus 1.397 t minus 8.35 equals to 4.886, 0.505 times equals to 18.03, and 18.03 is, it's equals to 6.03 p.m. So this shows that the boat can dock from around 11:07.7. This is around 11.12 is equals to 11:07 to a.m. 11:07 a.m. to 6.03 p.m. It is when the tie is equal or above 12 meters. Yep, so that is my full solution. Thank you for watching my video. Have a nice day.